Implement Etherchannel. This topology. 2 PCs, PCA, PCB, 2 switches, S1, S2, and between switches connections using fast Ethernet 1 and fast Ethernet 2 on both sides. Okay, 1 and 2. Fast Ethernet 6, 2 PCs, addressing table, switch 1, switch 2, PCA, PC2, 10.11, 10.12, 20.3, 20.4. Okay, belongs 1020, 999, 1000, 1000 for the native. Build the network, already done. Cable the network, already done. Configure basic settings. Assign a device name to the switch. Okay, for example, on S1, command line interface, enter, enable configure terminal, hostname S1. Okay, these another basic configurations were made in another lab, so for me it's optional, not necessary for this lab. Go to S2. Enable configure terminal, hostname S2. Configure PCs. Okay, use the addressing table PCA, PCB, PCA. And 192.168. 20.3, subnet mask 24, PCB 192.168, 20.4, subnet mask 24. Create VLANs and assign switch ports. Create VLANs on the switches. On both switches, create and name the required VLANs from the VLAN table above. This is the VLAN table and configure on both switches. S1, VLAN 10, name, management. VLAN 20, name, clients. VLAN 999, name, parking underscore lot. VLAN 1000, name, native. Same way on S2, VLAN 10, name, management. VLAN 20, name, clients. VLAN 999, name, parking underscore lot. VLAN 1000, name, native. Configure and activate the management interface on each switch using the IP address information in the addressing table. Okay, on S1, on VLAN 10, use this IP address and subnet mask. Go to S1, exit, interface VLAN 10, be careful, VLAN 10, IP address 192.168.10.11, subnet mask 24. Okay, and now shut down. On S2, VLAN 10, 10.12. Exit interface, VLAN 10, enter IP address 192.168.10.12, subnet mask 24. No shutdown. Enter. Assign all unused ports on the switch to the parking lot VLAN. Configure them for static access mode and administratively deactivate them. Okay. Parking lot 999. All unused. Okay. I'm using Gigabit Fast Ethernet 6, 1, and 2 on S1. Okay. Interface range, Fast Ethernet 1 and 2 in use, 3 to 5, 6 in use, Fast Ethernet 7 to 24, and Gigabit 0, 1, and 0, and 02. Enter. Okay, this is the range of unused ports. Static access mode. Switch port mode access. Parking lot VLAN. Switch port access VLAN 999. Same way on S2. Okay, ports in use S2, 1, 2, and 18. Okay, in my case, I'm using 1, 2, and 6. Okay, connect this PCB to 18. Okay, 1, 2, and 18 in use. Okay, now it's very good. And the unused ports are interface range, Fast Ethernet 1 and 2 in use, 3 to 17, 18 in use, Fast Ethernet 19 to 24, and Gigabit 0, 1, and 2. Okay, these are all unused ports. Enter. Switch port mode access. Access VLAN 999. Okay, this range is this range here. Okay, for VLAN 999. Very good. Assign VLANs to the correct switch interfaces. Assign used ports to the appropriate VLANs specified in VLAN table above and configure them for static access mode. Okay, use this table. Okay, use VLAN 20, the client's VLAN, for the PCs. Because S1 use Fast Ethernet 6 for VLAN 20. Okay, 6 for VLAN 20. And on S2, port 18. Port 18 for VLAN 20. On S2, port 18 to VLAN 20 for clients. Okay, and configure this. Okay, S1 Fast Ethernet 6 to VLAN 20. S1 interface Fast Ethernet 6. Switch port mode access, switch port access VLAN 20. On S2, interface Fast Ethernet, in this case is 18. 18 on S2 VLAN 20. 18 switch port mode access VLAN 20. Very good. Be careful. Show VLAN brief to verify. S1 and show VLAN brief. Okay. VLAN 20, fast Ethernet 6, 999, all unused ports. S2 and show VLAN brief. VLAN 20, fast Ethernet 18, 999, all unused ports. Configure AO2.1Q trunks between switches. Manually configure interfaces Fast Ethernet 1 and Fast Ethernet 2. Fast Ethernet 1 and Fast Ethernet 2 on both switches. Change the switch port mode on interfaces to force trunking. Use the interface range command. S1. Configure terminal interface range Fast Ethernet 1 and 2. Switch port mode trunk. Force trunking. Set the native VLAN to 1000. Switch port trunk native VLAN 1000. Specify that VLANs 10, 20, and 1000 are allowed to cross the trunk. Okay, switch port trunk allowed VLAN 10, 20, and 1000. Okay, enter. Okay, very good. S2, the same configuration. Configure terminal interface range Fast Ethernet. Okay, interface range Fast Ethernet 1 and 2. Switch port mode trunk. Switch port trunk native VLAN 1000. Okay, switch port trunk allowed VLAN 10, 20, and 1000. Enter. Okay, interface range, switch port mode trunk, switch port trunk native VLAN 1000, switch port trunk allowed VLAN 10, 20, and 1000. Verify, show interfaces trunk. S1 and show interfaces trunk. Okay, 1 and 2 trunk interfaces, native VLAN 1000, allowed VLANs 10, 20, and 1000. Okay, show running config. Fast Ethernet 1, native VLAN 1000, allowed VLAN 10, 20, 1000, mode trunk, Fast Ethernet 2. Same configuration, go to S2 and show interfaces trunk. Fast Ethernet 1 and 2 trunking, native VLAN 1000. Okay, it should be the same native VLAN on both sides. And allowed VLANs 10, 20, and 1000. Show running config. Okay, the same configuration. VLAN, native VLAN 1000, allowed VLAN 10, 20, and 1000, mode trunk. Same configuration on Fast Ethernet 2. Very good. Why is the VLANs in spanning tree forwarding state and not branded? Entry different for Fast Ethernet 1 and Fast Ethernet 2. Okay, on S1, for example, show spanning tree active. Enter. Okay, active. For example, on VLAN 1000, fast Ethernet 1 is root role, and fast Ethernet 2 alternating port. If fast Ethernet 1 is the root, okay, if fast Ethernet 1 is the root on S1, that means S2 is the root bridge. And alternating port is this orange port, fast Ethernet 2 on S1. And go to S2, show spanning tree active. For example, on VLAN 1000, fast Ethernet 2 and 1 designated ports. Okay, on S2, 1 and 2 designated ports. And this bridge is the root. S2 is the root bridge. Okay, the answer here is the spanning tree has placed fast Ethernet 2 on S1 in alternating role, blocking state. Okay, implement and verify Etherchannel. Create LACP based Etherchannel using fast Ethernet 1 and fast Ethernet 2 using group number 1. In both switches, actively negotiate the Etherchannel protocol. Use interface range command. Okay, on S1, configure terminal, interface range fast Ethernet 1 and 2, shut down. Don't forget that. Okay, to avoid issues and problems. Channel group. Okay, channel group. Number one mode LACP actively. So that means use active keyword, active command. Okay, active is for LACP. Active is for LACP unconditionally. Enter. Okay, go to S2. Enter. Configure terminal. Interface range fast Ethernet 1 and 2. Shut down. Don't forget that. And the same configuration. Channel group 1 mode active. Enter. Go to S1. No, shut down. Go to S2. No, shut down. Okay. On S1, create and port channel interface port channel 1, and S2, create and port channel interface port channel 1. Okay, very good. After the other channel is configured, a virtual port channel interface is automatically created. Now, interface port channel 1 represents the logical interface of bonded physical ports fast Ethernet 1 and fast Ethernet 2. Additionally, the port channel will inherit the configuration of the first physical port added to the Etherchannel. Okay, verify this here and for example on S1, enter and show running config. You configure it fast Ethernet 1 and fast Ethernet 2 with native VLAN 1000 and allowed VLAN 10, 20, 1000 and mode trunk. The same way for fast Ethernet 2. Native VLAN, allowed, and mode trunk. But look at this, interface port channel 1 automatically uses the configuration of the first physical port is fast Ethernet 1. And mode trunk, native VLAN 1000. And port channel 1 now has native VLAN 1000 mode trunk automatically. The same way on S2 and show running config. Okay, port channel 1 native VLAN 1000 mode trunk. Okay, show interfaces trunk to verify. For example, on S2, show interfaces trunk. Okay, the trunk port is port channel 1. The connection to S1. This is native VLAN 1000. What does the port channel 1 represent? A logical grouping of physical interfaces for Ethernet 1 and for Ethernet 2 is now seen as port channel 1 or port or PO1. Show Etherchannel summary to verify. Go to S1. Okay. Show Etherchannel summary. Group 1, port channel 1, SU. Okay, S means layer 2 port, and U in use. So it's very well configured. Protocol LACP and ports, physical ports, fast Ethernet 1 and fast Ethernet 2. P is for import channel. Okay, go to S2, verify. Show Etherchannel space summary. Enter. Okay. Group 1, port channel 1, SU, LACP, physical ports, fast Ethernet 1 and 2. And go to PCA and ping PCB. The IP address of PCB is this, 20.4. Ping to 192.168.20.4. Enter. Success. Okay, the ping to S1 and S2 will not be possible because you need a layer 3 device like a router or layer 3 switch to make the routing between the VLANs.